Question 2 asks us to sketch this curve. Now we already know roughly what this is going to look like, because we've got a negative in front of an x squared, which means it's going to be an upside down parabola, with a constant term, which means it's going to translate up, and no x term to move it left or right. So what will this look like? It will look something like this, where this is 9, this is negative 3 over 2, and this is positive 3 over 2. So that's what we're aiming towards. However, this chapter wants us to look at it in terms, this chapter wants us to look at it in terms of a translation of this graph y is equal to f of x. So let's start with, let's try and get back to where we could have begun. So this is actually y is equal to 9 minus 2x squared. Right? So we could also think of this as y is equal to negative 2x squared plus 9. So what transformations do we see upon our curve x squared? So if we just start with, if we just look at that. If we start with x squared, now there is no horizontal translation. What we see though is a scaling parallel to the x-axis by factor 1 over 2, by factor half. So what is this going to look like? This is now going to be half the size that it previously was. That takes care of this. Then we see a negative. What does the negative do? This flips it up into the y-axis. So let me change to blue now. Now it's going to look something like, it's going to look something like this. So a reflection of this graph in here, the smaller one. And then we take the plus 9 in the end, and we move this graph up here, so that it becomes like this. So this is our final graph. We can look at this a little bit neater. Of course, we're going to label these points and we can find them out fairly easily. So that point there is the y-intercept, that's 9. And by solving for x, we can find that this is 3 over 2. This is negative 3 over 2. So we can also check what we've done by keying it into GeoGebra. GeoGebra is a free dynamic geometry software that also allows you to plot curves. So we just key in y is equal to 9 minus 4 times x to the power of 2, and we can see that indeed we do get a graph that cuts at 9 on the y-axis and cuts the x-axis at positive and negative 1 over 2. So that is what question 2 looks like.